Janet Kuypers.
Hey!
I thought I would read elements from the periodic table of poetry. And for a set of 3, I have 2 that I was, they're going to go to get a car. They got to get the poems out of the car. But, but the first poem that I wanted to start with is actually one about science, and it's a long one. So you're going to get your astronomy lesson.
Oh, good.
For having this one. I can't believe I pulled this off for an element number 5 in the periodic table for boron. This is a piece, you'll have to bear with me since I said it's a long one. This is called Boron from the Big Bang. The Higgs boson, the Higgs particle, the God particle, as some have called it. It's an elusive elementary particle theorized about for nearly half a century. They call it the God particle because it might have created all matter. You see, scientists are trying to figure out how the Big Bang started to evolve. You see, the theory is that all of the universe's energy, when it was all created from this massive explosion from nothingness, well, the question remains, how did any of that energy turn into matter? Because during the first few minutes of our universe after the Big Bang, the temperature was so hot that it was too hot for any binding energy that could have supported any matter, even hydrogen or its isotopes, deuterium. With temperatures so hot, this bottleneck delayed the formation of anything in our universe until the universe was cool enough to make anything out of anything. But just a few minutes after the Big Bang, elements burst forth because the universe suddenly got cool enough. But at 20 minutes after the Big Bang, the universe was suddenly too cool for nuclear fusion or nucleosynthesis, and that is when elemental abundances were nearly fixed. That meant hydrogen, helium, and trace amounts of lithium, beryllium, and boron were the elements formed in the first 3 minutes of the Big Bang. Sorry, any elements starting at carbon or higher were only formed after stars were around to create them. So, the creation of matter out of energy during this formation of our universe only happened in an insanely brief period of the universe's history. It was just this was it just the insanely hot temperatures of this insanely short period that actually did it? And then, what does this actually have to do with the Higgs boson particle anyway, right? Well, scientists believe this Higgs particle is a part of the Higgs field, an invisible field of energy throughout the entire universe. That Higgs particle interacts with whatever energy passes through the Higgs field, and this interaction, massless particles, they trade their energy to gain mass when passing through. And this Higgs field is the beginning of our universe, and it helped create matter, which helped create us. Higgs helped create matter, including the first elements in the universe, from hydrogen to the comparatively heavy boron. Only 5 atoms. It's just the tiniest difference to make. Yeah, 5 electrons is heavy for the formation of the universe. Yeah, boron, which helps keeps our bones strong. Boron treats osteoarthritis. Boron helps muscles. And when it comes to trying to understand this universe, it also improves our thinking skills. We've known of boron for thousands of years, from the deserts of Tibet or from China and glazes that was used in, actually even in Persia before it got to Italy, where it was then used for medical purposes. Well, knowing how long we've used borax for cleaning, or even the borons used to make a strong magnet, the strongest magnet ever made, it's nice to know that we also understand how much this infancy of the universe element is vital in everything in our lives, from our muscles and bones to the very creation of the universe. Yeah, it's cool to see how scientists are starting to piece together how matter came together in the universe, because without that Higgs field and without that Higgs particle, energy would never have turned into boron to create anything, or even create us. I tried to put my astronomy reference into boron, right? So, and I usually ask for the middle one if anybody has a request for a number. What did you say?
She might. She might have a request.
Oh, you had a request?
I've been wondering a little about yttrium.
Yttrium.
Which one?
Yttrium.
Yttrium. Oh, look at you.
Yeah.
Now I have to find it in this thing. Forgive me. Red phosphorus. I know where it is. Find it. Well, it'll take me a minute. Why? I can't find anything. There it is. No, that's yttrium. Sorry. See, now I gotta look up. All right. See, and because it's centered, I have to go looking for the letter. And I heard you, and I'm going to find. Why can't I find it? Is it not on this page? I keep finding yttrium. Thallium. I know it's in here. You can use my phone since you're not taking pictures of it, and give me a number for it, and I might be able to find it. And I will do another one, and then I will do this one because I can't find it in the book. But I will do it. And I'm going to put bookmarks on. So he's going to look this up, and in the interim, I'm going to do the other one that I was going to do. I will do it afterward. I can't find it in my table of contents, and I don't want to make people wait. So I'm going to do this one, and it's called Tellurium. When a couple is meant to be together, but at their cores, they're nothing alike, you can see them come together almost violently, and then their anger pushes them away from each other until they do it again and again and again. It's like they can't stop. They can't help it. They rush at each other for a mad embrace and then feel this insane attraction that they can't escape until they know, despite their lust, they hate each other so, and they do everything they can to break free. It's a sick cycle they're stuck in, this coming together and then pushing apart. There's electricity in the air. I hear that buzz whenever I walk by the street corner and see all these electrical wires crossing in every direction. I could hear the loose electricity jumping into the air. Do you know why electric wires are spaced so far apart and they're up high in poles like that? Well, that's because those tellurium metal alloy wires are up that high in the sky like that because they aren't even insulated. And they have a strong magnetic field with all that electricity coursing through them. If wires were closer to each other while in the air, the wires would swing toward each other because of the insanely strong magnetic attraction. In being drawn to each other, an arc may form between the wires, destroying them almost instantly. But then again, magnetism in the wires swings polarity 120 times every second because of electricity's 60 hertz frequency. And that means that those wires would want to repel each other as often as they were magnetically drawn to each other. So, yes, for 120 times every second, those wires would vibrate back and forth. So, if there is no electricity arc, those Tellurium metal alloy wires would vibrate so intensely and violently that they wouldn't even, if they weren't actually kept far apart, they would destroy each other, vibrating. Tellurium is used in other alloys with steel to make high-strength conductors. Abundant cosmically but rare on Earth, it's often found abundantly combined with gold. In the first gold rush, this mix looked like waste, so they used it to fill potholes and sidewalks. Once they actually realized it was tellurium and gold, it was a second gold rush. Acute poisoning with tellurium is rare. Most organisms tolerate tellurium. Organic tellurium has antioxidant activity, and it can even be used to identify pathogens responsible for diphtheria. Its optical refraction makes it perfect for glass. It's even used in color ceramics and gives rubber heat resistance. In copper, iron, lead, or stainless steel, it makes the metals more machinable. Improving solar cell efficiency in electric power generators, it's so strong that it can help any energy. I don't know. Maybe that explains why I've been feeling this electricity in the air.
Tellurium. I see it.
I know. What is it, 109?
39.
Oh, was that? Oh my gosh, I might have been on the second page. That's 1539. There it is, 136. I think, I don't know. Well, all right, thank you. And I'm going to do this as patient 136. I have to find it in this book, little girl. 136. And Yttrium 136. My pages are too tiny. 137, 136. Yttrium. Hi, I'm doing this for you. Finally, I got it for you. This is Yttrium. Recently, NASA sent a rocket to collide with a comet to gather comet dust so they could learn about comets, which contain the primordial parts of what started this solar system. A compact disc bearing my name was mounted on the impactor spacecraft shot into space on this deep impact mission. Although this was the first NASA mission with my name on it, it was also the first NASA mission to learn about what's deep inside a comet. The rocket combustion chamber that shot this impactor spacecraft on its collision course with Comet Tempel 1, it had a silver-colored lining with an alloy of nickel, chromium, aluminum, and yttrium. Yttrium makes sense because yttrium has been used in places from MRI scanners to help us heal, or CRT cubes on TV sets to help us see. Yttrium makes element compounds stronger, good for stellar travel. Besides, the fact that yttrium is colorless, odorless, and not naturally magnetic gives it an added plus while being a part of the launching of the rocket I tack my name onto when looking for a comet. It'll help us see more than what's inside our bodies or what the cathode ray tube ever could. And it helps us see what we can see and where we came from in this solar system, too. Yttrium. It's colorless and it's a beautiful stuff. So thank you for that.
What kind of audience we have. Oh,
Thank you.